Welcome to another exciting episode of Chemistry 2 with Mr. Hader. So that's my radio voice. Maybe I can get a job in radio presenting, or maybe I can't. Now, anyway, what we're going to cover, just to let you know, is we're going to look at ionic structure and ionic bonding. Okay, and in order to do that, we need to revisit a particular section which we looked at in video 1. Now, what we're going to be revisiting is where the metals are and where the non-metals are. So here, anything to the left of the stepped line of aluminium to polonium, all of this side, just to recap, are metals. Okay, so all of these are metals, right? And all of this side are non-metals. Now the question is, why is this important? But before I get onto that, I just want to mention this because I'm not sure if I mentioned it in the first video, so I should have, but I can't remember if I did, so I'm just going to mention it here. All of this block is called the transition metals. Okay, and what you need to know about this in particular is that they can form colored compounds. Okay, they form colored compounds. Okay, so that's just something I've maybe forgot to mention, so I'm just mentioning it here. So back to the point though. Why is it important to know where the metals and the non-metals are? It's because ionic bonding, you see, ionic bonding is the bonding between metals and non-metals, between metals and non-metals. Okay, so now what I'm going to do, I'm going to break it down to help you to understand exactly how it works and how you can figure everything out, because it's not that difficult. Okay, so going back, and this is why it's important that you know all of this stuff. Going back, I'm going to say, if you remember, or you should remember, in any case you should remember that this here is group 1. Group 1 has 1 electron in its outer shell, right? You know, or you should know, that group 2 has 2 electrons in their outer shell. You should know that group 3 has 3 electrons in its outer shell. Group 4 has 4 in outer shell, 5, 6, 7. This group 0 or group 8, same thing, has 8 electrons in its outer shell. So why is this important? Because number one, you need to know that metals donate electrons. So they give electrons away. So give electrons away. Right. Now if you notice and if you remember that electrons have a negative charge, which is why I've drawn this negative sign here. So anything to the left of the aluminium stepped line, these will all give electrons away. Right, so bear with me now. If we go with lithium, remember lithium has 7 at the top, 3 at the bottom. We're interested in the bottom number. So lithium is going to have 1, 2, 3 electrons. So it's going to give this electron away. So metals donate and give away the outermost electron. Okay, it's very important. Outermost electron. So it's going to give this one away. Now if I throw off a negatively charged electron from lithium, what charge will lithium have? It will have a charge of +1. But we don't write the 1, we just write plus. Okay. Right, so now the way I explain this to my class is, let's imagine, close your eyes guys and girls, think of the most disruptive person in your science class. That person is an electron because they carry with them a lot of negative energy, a lot of negative charge. Now let's imagine your teacher does you a favor and chucks that negative kid out of the classroom. What will happen to the atmosphere of that class? Will it become more negative or will it become positive? Well, because you've chucked out that negative kid, it's going to become more positive. Similarly, if the metals are losing negative electrons, they're going to become more positive. So if you look at, let's take magnesium. Magnesium is in group 2, right? So how many electrons in the outer shell? 2. How many is it going to lose? It's going to lose 2 electrons. So if it loses 2 electrons, what charge will it have? Well, it's going to become positive by 2. Right? Aluminium is another metal. It's in group 3. So how many electrons in the outer shell? 3 electrons. How many electrons will it lose or donate? It's going to be 3 electrons. So what will be the charge? It's going to be Al3+. Right? You can take barium. Barium is in group 2. It has 2 electrons in the outer shell. It will lose 2 electrons, so it will have a charge of +2. Right? You can take gallium. Gallium is in group 3. It's going to have 3 electrons in its outer shell. It will lose those 3, so it will have a charge of +3. Let's take francium. Francium is in group 1, therefore it has 1 electron in its outer shell. It's a metal, so it's going to donate that electron. Once it donates that single electron, it's going to have a charge of +1. Now, as you can see, all metals in ionic bonding will have a positive charge. We've just seen that, okay? They will have a positive charge. Now, I'll just give you some examples. I mean, I've just given you loads of examples, but just to kind of like go through it quickly. Mg2+, Li+, Al3+, K+, Sr2+, Ga3+. Okay, so nice and easy. Okay, now all positive ions, so these are positive ions, are called cations, and the way to remember that is cations are positive. Pussy cats. So cations are positive, right? So that's how to remember that cations are positive. Now let's look at the other half of the story, because this is a story of 2 crossed star lovers, as they said in, I believe, Romeo and Juliet. So let's look at the non-metal. So all of these are non-metals, because remember, ionic bonds, guys, is the bond between a metal and a non-metal. I'm just breaking the story down for you, and really the ones that really often come up are these ones here. Okay, so group 7 and group 6. So let's have a look. How many electrons in the outer shell of group 6? Well, there's 6 electrons. How many electrons in the outermost electron shell of group 7? There are 7 electrons in its outermost shell. Now these need enough electrons to have a full electron shell. A full electron shell is 8 electrons. So if this has 6 already, how many does it need to make 8? Well, it's 2 electrons. So if you take the 2 electrons and give it to group 6, it's going to have a full outer shell. Happy days. Let's take group 7. Now with group 7, it needs 8 to remember to have a full outer shell. So if you take 7 and you give it 1 electron, it's going to have a full outer shell. It's going to have 8 in total. So if group 6 takes 2 electrons, and let's say we're talking about oxygen, so oxygen ends up taking 2 electrons, how much more negative has it just become? Well, it's become negative by 2, so we write 2 minus. Now let's take fluorine. Fluorine, how many does it need? It needs 1 more to make it full 8. So when it takes that 1 electron in, what charge does it have? Well, because it's only taken in 1, it'll have a charge of 1, negative. But we don't write the 1, we just write negative. Okay, that's just convention. It's just how it's done, guys and girls. So now let's look at crossing over and working out any single electron, any single compound. We can work out its formula using this crossover method. Okay, so they might ask you, they might give you some elements, and they'll say, well, if you cross these two over, if you join these two by ionic bonding, a metal and non-metal, what is its chemical formula? Okay, or molecular formula. So let's say they give you Be. Okay, so they give you this Be and they say to you cross it with or join it with F. Okay, while Be is in group 2, so we know it's going to lose 2 electrons because it's a metal. So let me just draw the metal line as well, just so that we all happy with that. So Be is a metal, it's going to lose 2 electrons because it's in group 2. F is going to need to gain 1 electron because it's in group 7, so it's F minus. Now, so once these react and join together, what you guys need to do here is just swap the number over. So because it's a minus, that represents the number 1. So this number 1 is going to go to beryllium. So how many berylliums are we going to have? We're going to have 1. How many fluorine are we going to have? Fluoride. We're going to have 2. So that number comes across to the fluorine side. So this formula is BeF2. Okay, so let's do it for another one. Let's do it for Na. So sodium is going to cross over with fluorine again. So let's do fluorine again. It could be chlorine, doesn't matter, it's all the same thing. I'm just coincidentally choosing fluorine. You can do this for anything, guys and girls. I'll tell you what, why don't you have a go yourself and then see if you're correct. So pause the video. If you're not pausing, here's the answer in any case. Na, it's in group 1, so it's going to lose 1 electron, so it's going to become positive. Fluorine needs an electron, so it's going to become negative by 1 because it's going to accept 1 electron. I'm going to swap the numbers over, and what you're going to have, how many sodiums you're going to have? Well, that's number 1, so that's going to go Na, just 1. How many fluorines going to have? That's 1 as well, so it's NaF. That's the end answer. Next, let's go for another one. Let's go for magnesium. Let's do another color, like colors. Let's do magnesium, which is in group 2, so I know it's going to have a charge of +2 because it's going to lose 2 electrons from its outer shell. And we're going to react it with, let's react it with bromine, which is here. So again, it's the same thing, guys, because bromine is in group 7, it's going to gain 1 electron. Let's cross the numbers over. Right, so how many magnesiums are we going to have? Well, that's 1, so Mg is 1. How many bromines are we going to have? So we're going to cross this number over. It's going to be Br2. There's a 2 there, guys, 2. Br small 2. Let's go with sodium and oxygen now. So I've got sodium here, which is in, we've already used it, so let's go for potassium then, because we've already used sodium. So potassium and oxygen. Now it's exactly the same things, guys. So potassium is in group 1, so it's going to lose 1 electron, so it's going to become positive. Oxygen is in group 6, so it needs 2 electrons. So if it's going to get 2 electrons, it's going to make 8. 6 plus 2 is 8. It's going to have an overall charge of 2 negative. Cross over the numbers. How many potassiums are you going to have? Well, you're going to have 2. How many oxygens? You're going to have 1. K2O. Now let's look at some compounds. Okay, so it's a little bit different for compounds, but it's exactly the same thing. I'm going to get rid of this periodic table because we don't need it for compounds. Okay, so let's say they'll give you some compounds and they'll ask you to kind of work out the formula. So let's say they give you NH4 plus and they ask you that it's going to react with, oh god, ignore this. Okay, it's going to react with SO4 2 minus. So all you're going to do, guys, is you're going to cross over the numbers exactly the same. So the question is, how many NH4s are you going to have? You're going to have 2 because you're crossing this number over to this side. So it's NH4. Now you have to do brackets because what this is telling you is you're going to have 2 lots of this. Alright, so you're going to have 2 lots of NH4. And how much SO4 are you going to have? You're going to have 1 because that number's coming over here. So it's SO4. Now, a couple of things that I want you to note, guys. In everything, what you have is you had a positively charged ion and a negatively charged ion. I'm just writing it in shorthand. And they came together to join to form a neutral compound. Now, if you look at this example at the side, you've got your positive cation, you've got your negative anion. By the way, a negatively charged ion is called an anion. Right? And so these are positively and negatively charged, so they're both charged. But by the end of it, can you see any charges? No, because it becomes neutral. Very important. If you put a charge anywhere in the compound, in the resulting compound, it's wrong because there is no charge. So that's an example of one compound that we did. Let's look at another one. Okay, so let's say we've got Fe, Fe2, no, let's go Fe2 plus, so this is iron with a charge of 2 plus, plus a CO3 2 minus, which is carbonate. So what we're going to do is we're going to swap over the numbers. By the way, guys, what does this mean? This means we've got 1 carbon, 3 oxygens, and it has an overall charge of 2 minus. This means we've got iron with an overall charge of 2 plus. So swap the numbers over. So this number 2, is going to come to this side. So we've got Fe2. And how many carbonates are we going to have? We're going to have this number come over to this side. It's going to be CO3. And we're going to have 2 lots of CO3. Okay, so if you notice, your cation, your anion, your neutral compound. Next, let's say we had now one other thing that I want to say to this, because this is a 2 to 2 ratio, so it's, in other words, it's a 1 to 1, we can cancel it down and say FeCO3, because you can cancel that down. Okay, finally, let's look at this one here, which is what would happen if the Fe, if the iron was 3 plus. Okay, so its iron is 3 plus, not 2 plus anymore, and we're going to add that with CO3 2 minus, so the same carbonate. So we're going to swap the numbers over. So that number is going to come over to this side, this number is going to go over to that side. So it's going to be Fe. How many Fe's do we have? Well, we're taking this number here, so it's Fe2. And how many carbonates are we having? We're going to take that number over here. We're going to have 3 lots of carbonates. So guys, remember what this means is you got 1 carbon, 3 oxygens, and it has an overall charge of 2 minus. So we've got our positive cation, our negative anion, forming a neutral compound. Very important that you can state that, okay? Now, the next thing, what you need to know is about how to actually draw what happens between the electrons for sodium chloride. Okay, so let's go with sodium chloride. So now firstly, we know sodium is in group 1, so it's going to have charge of +1. Cl is in group 7, so it needs 1 more electron to make it 8. So if we add these two together, it's swap the numbers over, you've got NaCl. Right, nice and easy. Now what happens on an electronic structure? So for this we're going to need our periodic table. So you're going to look in your periodic table and you're going to see that Na has a top number of 23 and a bottom number of 11. So Na has a top number of 23 and a bottom number of 11. So we've got Na 23 and 11. And because we're looking at electrons, it's the bottom number we're interested in. And chlorine has 35.5, sorry, and 17. Right, so it's the bottom number again because we're looking at electrons. So now that we've got that from our periodic table, I'm just going to get rid of my periodic table. And what we're going to do is we're going to draw the electron structure of sodium. Okay, so sodium is going to be 11. Now guys, if you think about it, if you want to know straight off how many shells and how many electrons it's going to have, well, how many shells, you can look at your periodic table. So if you remember that this is period 1, 2, 3, so sodium is in period 3, so it's going to have 3 shells. Okay, so I'm going to draw 3 shells straight away. So sodium has 3 shells because it's in period 3. 1, 2, 3. And chlorine, let's see what group that is in, or what period that is in. So chlorine is in period 1, 2, and 3 here. So period 1 is at the top, period 2 is here, and period 3 is all across here. So that's period 3. So it's going to have 3 shells as well. So chlorine is going to have 3 shells. 1, 2. So let's have a look and draw an 11 here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So sodium is in group 1, so there should be 1 electron in the shell. Happy days. Let's go with chlorine now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, and 17. Chlorine is in group 7, so it should have 7 electrons in its outer shell, and it does. Happy days again. So as you can remember, that, or if you can't remember, you just look at your periodic table. Let's bring it up again. Sodium is on the left of the aluminium, so sodium is group 1, and it's a metal. And chlorine is the non-metal, okay, because it's on the right hand side of the aluminium step line. So what we're going to do here now is we're going to see a transfer of electrons. The electrons will transfer from the metals, because remember metal donates, and it's going to go to the free electron of the non-metal. So if what we had here to begin with was 2, 8, 1, and this is 2, 8, 7, so that's to begin with. Once the electron transfer occurs, this is what we're left with. So we've got sodium, which has gotten rid of this 1 electron, so we're not going to have this outer shell anymore. We're going to have now 2 shells only, so it's 1, 2, right? And it's going to be a complete outer shell, so I can just do 2 and draw my 8 on here. So there's 8 in the outer one because my other one's gone. And now because we got rid of an electron, we need to represent that with these brackets. Now if we got rid of the electron, what charge is it going to have? We know it's a plus because metals have a plus charge. It's got rid of 1 electron, so it's going to be plus 1. And also what we're going to have is the chlorine. Now the chlorine, it went from, so before we go on to chlorine, this now has an electron configuration of 2, 8. Now with the chlorine, what we're going to have is we're still going to have the 3 shells, because you still got the 3 shells. So let me just undo that. Okay, let me just undo that. Oops. Undo. Okay, so undo that. So the chlorine, I'm just going to make it smaller so that it can fit on. So 1, 2, and 3. Right, the chlorine is going to have an extra electron, so you're going to have 2 in here. You're going to have 1, 2, 3, 4, 5, 6, 7, 8 here, and then finally you're going to have 8 here, because it's got that extra one from the sodium. And we need to show that it's gained an electron, or that it's changed in charge, so we put the square brackets around it. It's gained 1 electron, so we're going to put a negative there. So finally, this comes to the properties of ionic bonds, and what we can say is that they have a high melting and boiling point. Because they have a strong electrostatic force of attraction. And basically, in simple terms, what that means is that this has got a really strong bond, because the negative and the positive join together to form an attractive force, which is difficult to break. And so that's why it has a high melting and boiling point. Okay, and that concludes, I believe, ionic bonding. I'm just going to have a look and make sure that I haven't missed anything out. So that's ionic compound. That's good. We've covered pretty much everything. Now I haven't done the higher stuff yet. I would more than likely make a higher video right at the end. Okay, so I'm gonna stop that here and call it and upload this one as well. Okay, so good boy.